Hello students, let's read our question. These triangular prisms are similar. What is the value of x? So I'm gonna highlight here, these are triangular prisms, but I can see it here because a picture is given. I'm not gonna highlight that. And then it says that they are similar. This is important because if they say similar figures, then I automatically know that proportions work. So that's one option right there. And now the question is, what is the value of x? So I'm going to identify my x. I'm going to put this in blue, and I see the x is right here. This is what we don't know. Okay, I did circle, underline, and box the question. Now for elaborate, what I'm going to do, because I have similar figures, my strategy is going to be highlight corresponding quantities using the same colors. This side then I know corresponds to this side. You see that, guys? I'm gonna use orange for the other side. And this side right here, which is the base of the prism, I put it in orange. And the same right here. And I say this is the base of the base. I know it sounds kind of maybe a little bit weird, but the bases are always parallel to each other. So these ones that I put in blue right here are the bases. And this orange here is the base of the base. That's why. So my next step after I identify corresponding sides will be set up my proportion. Maybe your teacher can get started in a different way. It doesn't matter really. Many teachers can do it in different ways because there are many ways to set up the proportion. But there is just one thing that is right. We always set up corresponding quantities in the same row. So I'm going to show you what I mean. Okay, I always like to get started with a figure on where I have all complete information, and the figure where everything is complete is this prism on the left side. So I'm gonna get started on that one. What I'm gonna say is this: when I have 21 meters, on the other side I have 11.2, and I'm gonna put my quantities in the colors that they correspond. See? Okay, great. And then I'm gonna equal that to the sides on the other similar figure, and then 21 meters I know corresponds to the x, and then this value here is in meters, and that is 3.2 meters. I'm gonna write it right here, 3.2. Now what is important here, guys, is if you can say no, but my teacher, she likes to get started, for example, you can say with a small shape, and she likes to say that 3.2 meters is the same as x, which is true, right? Okay, now I'm gonna put the colors, and then if she uses this or he uses this, then you can say on the other shape, okay, so if this is 3.2, then here the teacher will put 11.2 m equals 2, and on the other side 21 meter there and there. Now the interesting part here, guys, is you see I have to have the colors in the same row, right? Like here on the bottom is orange to orange, and on the top blue to blue. They are in the same horizontal row. Now here this teacher did it in the same way, but orange to orange vertical and blue to blue vertical. And you're gonna see why it gets the same answer, because now we know here that when we have three values and one unknown, we use proportions. Finding the parent will be kind of difficult because we have decimals. Then the numbers are not that friendly, and we all will multiply the two numbers across, right? In this case will be 21 and 3.2. Now look at this other setting. What are the two numbers that are across? 3.2 and 21. So, and yes, so you see, it really doesn't matter. You can get started in any way, but just make sure you set up corresponding quantities. And the way to know is by if you have the same color in the same row, either horizontal row or vertical row. So I can use any proportion that I want. Now I'm going to set up the proportion to work it out. So I'm going to say that my steps were step 1, identify corresponding sides. Step 2, set up the proportion. And it can be in either way. That's what I'm going to say. This is also number 2, another way. Step 3, I'm going to see how I'm going to work it out. And this is x equal, this is the one that we're looking for. This is the unknown. It's going to be equals to 21 meters times 3.2 meters. You see these two that are across, and then we divide by the one that we haven't used yet. by 11.2. I'm going to identify the colors, the 21 in blue, the 3.2 in orange, and the 11.2 in orange as well. So I always have to have multiplying opposite colors because they are cross product, you see? And it doesn't matter if I set it up here or here. If I set it up correctly, I'm going to always have opposite colors here and then the other color here. Great, guys. So now we know what we have to do. And I'm going to just highlight my step. That was my step 1, 2, 3. Now I'm gonna do my step 4. That's gonna be my operation. So right here, what I'm gonna say is I'm gonna multiply these two numbers. Can you please multiply with me? We're gonna multiply 21 times 3.2. It says 2 times 1, 2. 2 times 2, 4. Don't bring down the decimal point. That's only at the end. Because we already multiplied this place value, we use a placeholder right here. 3 times 1, that's 3. 3 times 2, that is a 6. Now we're gonna add those numbers. 2 plus nothing, that's 2. 4 plus 3, that's 7. And 6 plus nothing, that's a 6. Now we're going to identify the decimals in each factor. On the first one, there's none. On the second one, there is 1. And here there was 0. So the total is 1 digit. So this would be like this. So it means that when I multiply 21 times 3.2, we got 67.2. I bring down this division symbol here, right here, and then I bring down the 11.2 meters, and I put it in the same color so you can track what I'm doing right here. See, guys? Great. Now, so my next step will be dividing. I'm going to use the long division symbol here. The number needs to be 67.2 divided by 11.2. That was in orange. You see? So this is exactly the same as this. Now, because we have a decimal in the divisor, I cannot do it. I have to multiply by 10 in the divisor and multiply by 10 in the dividend. When I multiply, I make my number bigger. Isn't it? How many times bigger? One place value, because the 10 has 1 0. You see? Basically, we move the decimal point one place value towards the right and one place value towards the right, because that way we can eliminate the decimal point here. So now my division is going to look like 11.2, no more. Now it's going to be 112. We have the division symbol, and instead of having the decimal between 7 and 2, now goes towards the end. 672 there. Now I'm gonna divide 672 into 112. 112 into 6 doesn't work. The 6 is way too small. The 7 is not gonna work because this is smaller than 112. I have to go all the way, so the answer must be on top of the 2. I always like to multiply by 5 because the 5 tells me if I need to go higher or lower. So I'm going to multiply here on the side. I'm going to say this is a continuation of step number 4 right here. Okay, so I'm going to multiply this 112 by 5. And let's see what we get. 5 times 2, that's a 10. 0 and we carry 1. 5 times 1 is 5 plus 1, that's 6, and 5 times 1, that's a 5. Okay, we are still far from 672. Now we're gonna try by 6. I'm gonna say 112 times 6. Can you help me to multiply? 6 times 2, 12. 2 and we carry 1. 6 times 1, 6, plus 1, 7. 6 times 1, 6. Yay! So this is our number. Awesome. So we're going to put it right here. And we know that 112 times 6 is exactly 672. So we will have no remainder. So where does this 6 goes, guys? It's going to be right here. Remember, this is what we're looking for. So this x should be 6. And we bring the units that we have on the left side, which are meters. This should be our answer. Let's look at the answer choices, guys. It is letter B. Awesome. Thank you, guys.